Hello, everyone. Welcome to the very first webinar from National Technology Alliance's MOSA Catalyst community. This is entitled Demystifying MOSA for Stakeholders. And just to share a little bit for you, NTA is a nonprofit. We connect early stage innovations with curated opportunities. So that could include industry scouting requests, SBIR grants, other transaction requirements, federal innovation funding, and much more. So we're here today. My name is Laura Murphy. I'm the Operations and Communications Director for NTA, and I'll field your questions behind the scenes today. If there's anything you'd like to ask, we're looking forward to getting to that. John Stow, our speaker, is the MOSA Catalyst Community Co-Chair, and he will equip you with the skills needed to effectively explain MOSA to a diverse set of stakeholders. He'll answer your questions at the end of the webinar. So if you have those as we go along, please use that GoToWebinar control panel that you may see to go ahead and pitch those over. So don't wait, you can ask them throughout, and we'll get to as many as we have time for during the webinar, and any that we don't, we're happy to follow up with you after the webinar directly and make sure that you get your questions answered. So without further ado, I'd like to pass the mic to John Stow. He's a consultant for Advanced Technology International, and he's the co-chair of the MOSA Catalyst community within National Technology Alliance. He's an all-around MOSA expert. We're honored that he's here joining us. So thank you, John, and we look forward to all that you have to share.
Great. Thanks, Laura. Happy to be here. And so I know we've got to move fairly quickly today because this is intended to be a very high-level discussion of MOSA at the how do I talk to a stakeholder level. Now, there are a number of presentations. We've been doing this for a while. So I looked at the registration list. Laura shared that with me just beforehand, and I saw some names I recognize. And so some of us in this community, we have been MOSA practitioners for the past decade or longer. Open systems concepts are not new, and we used to call it open system architecture, and so there's a lot of that legacy stuff out there. But the problem is that many of us interact with stakeholders on a daily or weekly basis where they hear the term MOSA and they treat it like a buzzword. And in many ways, that's kind of how cybersecurity was, I don't know, 10 years ago, 15 years ago. And before that, object-oriented programming was a big buzzword. Nobody really knew what it was, and there was all this mystery around it. And then as people started putting it into practice, a lot of that mystery just kind of disappeared. It kind of demystified itself by use. And I think that's where we are with MOSA. MOSA is ready to move into action. We are seeing it in practical ways. But there is a lot of confusion out there in the stakeholder community, and there's still a lot of mystery around it that doesn't need to be there. So I'm hoping today we can get to that very high level. We won't get too deep in the weeds, but if you want to go in the weeds, let me know and we'll go there. And there's lots of places where we can get that information. So I want to start off today with something, and for those that have followed me for a while, I came up with this a couple of years ago, and I actually shared this at the International Conference on Software Architecture a couple of years ago, specifically kicking off before our first MOSA Summit. What is it that's really driving the need to put a MOSA Summit together, to bring together these diverse communities that have been working on MOSA for a few years? And for me, it was this paradigm shift. And apologies to anybody that's seen any of my last couple of presentations, either at the Aviation Missile Technology Consortium or at last year's MOSA Summit, where I shared this same slide. I've got a couple of slides that are repeats in here. But the point is, these are the best ways to explain it to that diverse stakeholder who doesn't really understand what MOSA is all about. So in World War II, General Patton made a statement, and we have pulled this into the common lexicon. It's something that high school students are likely to know, even if they don't know a lot about World War II, and that is, you train like you fight. But that's not actually what he originally said. What he originally said was, you fight like you train. And it was an idea that was focused on the failures of training to prepare people for the war as it actually existed on the battlefield. And he made the observation that if we fight the way that we train, we're not going to win these fights. The observation was, you tend to follow the muscle memory of the way that you've trained. And if you fight like that, then you better train correctly. and it fixed a lot of things in the training system. It made training more realistic. It made training catch up with what the warfighter needed at the point of engagement. Well, that's where we are with MOSA. That is exactly the place where we recognize if we fight the way we currently acquire, we are not prepared for the next fight. So we must acquire like we fight in the way that we have learned to train like we fight. And part of what that means is that the evolutionary threat and that complex environment is forcing us to be able to increase the pace of technological change and implement new technology using modular and open systems across the entire DoD. That's the core issue. It's not about some deep technical issue. It's not just a software thing. And we'll talk about some of these myths. It is about changing the acquisition paradigm so that we can be modular, open, and agile in order to keep pace with the change as it really exists in the warfighting field. It's not a future thing. It is agile, modular, cross domains, and fast right now today. So that's the first major thing that we want to communicate to our stakeholders. What's next? Well, next is where are we with this? We've done 2 years of MOSA summits. We've pulled together a wide variety of stakeholders, MOSA practitioners in different ecosystems. And it was really the Catalyst community start is to recognize that people that were attending the MOSA summit came from a variety of different channels. We had strong participation from the open group for the FACE and SOSA communities. We had strong participation from the ground community in Victory and CMOS. We had strong participation from the Air Force with GARA, WOSA, OMS, as well as a number of technologies in communication, C2. We had work on the communities for hardware open systems technology, for next generation mission computing. We had a lot of communication with the model based systems engineering community. So we have tremendous success that we've obtained by bringing together this diverse set of communities, which really is now who makes the Catalyst community. We have 1,000 members in the MOSA Catalyst community. I know all of them couldn't join us on the webinar today, but we have also got strong government leadership support. And one of the things we want to do is draw those things together. So I'll give you an example of what that means. The DAU, Defense Acquisition University, and many of you may not even know this exists, right? The Defense Acquisition University is something that every person in the acquisition community on the government side is aware of. Most people in the industry side, especially in larger industry, are aware and may have taken some DAU courses. But if you're a startup or a venture capitalist or somebody that is looking at MOSA for a variety of reasons because of dual use technology, maybe you're a commercial vendor, you may not even be aware that there's a whole training set. But look at this. There's only about 70 members. Now we recognize the Modular Open Systems working group out of DoD headquarters. That's a couple of hundred people deep. There are a number of people that take the training that don't necessarily join this community of practice. So one of the jobs of our Catalyst community, one of the things we're going to do with the National Technology Alliance is we're going to amplify success stories just like this DAU, and you can find that with Google. So we have strong government leadership. We also have recognized that we have a strong community associated with this. We've got several hundred members in various different organizations like the Open Group FACE Consortium or SOSA Consortium or within the OMS ecosystem. But by bringing us together in the Catalyst community, we can strengthen and share information across those different domains. That'll become useful in a couple of slides. I'll show you where I think we're headed with that. One of the lessons, though, is that there's still a lot of confusion around how to fund MOSA. The belief that MOSA is baked into every program. Well, that's I don't know. Maybe I've heard that from several people because there's typically not a budget line item for modular open systems. There's a budget line item for the whole aircraft, the whole ground system, the whole aircraft carrier, submarine, and these large systems all have components. And so if you're a subcontractor, then your customer is the prime contractor. And if the government is saying they want MOSA, then they're telling the prime contractor, go get me MOSA. It's baked into your budget. We can do better. This is one of the major lessons that we're trying to address. And it's one of those communication points that you're going to have with seniors, leaders, and other stakeholders. We also recognize that there is this need to drive continuous innovation into the ecosystem, or bringing in ideas and technologies from outside in the commercial world, from new start ventures, from companies that have been doing defense innovation for a while and have new ideas that they want to get out into the hands of the warfighter. So we've got some good lessons that we're going to implement in future MOSA summits. So how do we get to the problem? Where is the mystery in MOSA? Sounds like we've been doing it successfully for a while. Sounds like there's a lot of success and a lot of good lessons that we're going to put into practice. So what's the problem? Where's the mystery? Well, one thing is that even though MOSA is now the law, and this was not true until 2021, right? In 2021, it was codified into the National Defense or the National Defense Authorization Act, or the NDAA. A few years before that, in 2017, there was a first pass for any new programs. In 2021, it was all programs. So every dollar of the defense acquisition budget has a MOSA implication, every single dollar. Now, there's also a speed limit. So what? There's going to be a lot of programs that are going to ignore that law. They're going to ignore it flat out. They're going to say, MOSA is something I'm going to I'll make a contractual requirement somewhere. And if I'm not under oversight, or I'll just say, hand wavy, hey, we did MOSA by putting this thing in our requirement somewhere down in the weeds. Sure, that may meet the letter of the law, but it certainly won't meet the spirit of the law. You want your program to be the one in the news that gets recognized for, if we had only done MOSA correctly, if we had only taken it seriously, we would have avoided this problem entirely. It is going to be far better for those organizations that don't treat it like the speed limit, and instead take it seriously and get behind the spirit of the law, not just the letter of the law. I'll show you what I mean on the next slide. So that's one of the major myths we have to bust, is that MOSA is just some buzzwordy thing, or that it's difficult to understand and no one can really define it. Sure, it's in the law, but I don't know what it is. Well, actually, that's a untrue. You can easily know what it is. Now, there is some confusion. Like I said, we've been working on MOSA for over a decade, and in the early days, there was a lot of hand wringing about how do we actually define it. Congress solved that problem for us. It's very clearly defined. It is very easy to read the Title 10 language. I'll show you exactly how to do that in just a second. And the mystery will go away if you just read what it says. Now, there's historical confusion. There is detailed confusion. Like, how do I actually put it into practice on my specific program? And that's our job as practitioners, to be able to say, take that abstract concept of a modular open systems approach and apply it to a specific weapon system. This is what we are actually empowered to do. But in terms of defining MOSA, it's very straightforward. It's an integrated business and technical strategy. And that leads me to my next myth, and that is that people think MOSA is just some technical thing. MOSA is just that's some technical thing that systems engineers work on. No, Congress defined it very clearly as an integrated business and technical strategy, which means that business they put first for a reason. They recognize it as the program manager who's responsible for implementing MOSA, not the prime contractor. Now, that means that the prime contractor is going to receive requirements about open systems. They're going to receive requirements that allow them to make a distinction between their intellectual property and the intellectual property at the interface to make it replaceable. Well, who wants to be replaced? Well, if you didn't win the competition, you want an opportunity to win again. So if there are 5 people competing and only one of them wins, the only one who doesn't want competition is the one who already won. Everybody else wants that open interface. So if we can agree, and that's what standards are largely about, is making an agreement about that interface to foster future competition. That is a business issue. It's not a technical issue. Now, there are technical implications of that. There is a technical implication not only of the physical interface, the data interface, the software interface, the specific domain issues around whether it's in aviation or autonomy or communication subset of requirements. All that's true. But we've been working on that technical stuff for so long that all of us that are at the practitioner level, we're not that concerned about the technical details of MOSA anymore. It is a business strategy first. And so if anybody goes, MOSA is just a technical issue, stop them right there and say, well, actually, it's an integrated business first and then technical second issue. There are some other common myths. We won't have time to get into them today. I'm happy to talk about these, but the idea that MOSA is not really put on contract, got a whole slide for that. The idea that MOSA is just dealt with by a bunch of standards, got a whole slide for that. And the idea that MOSA is just a software thing. Well, we'll talk about that in a little more detail. Clearly, it's more than that. So let's get into some of the nitty gritty, right? So what does the Title 10 look like, right? Right up here at the top of this slide, you'll see that there's the link. And I think Laura's planning on sharing the slide, so you'll be able to click on that link. You can also just type into your browser search engine Title 10, and then you'll get the actual website in all of its 1990s look and glory for the US code or USC. And you can jump to Title 10, right, which is the defense section of the US code, right? This is the law, right? You're actually going to be able to read it yourself. If you put it in a PDF and print it, it's about 15 pages long. It's not very complicated to read. And some of that 15 pages is all just like amendment and who it's named after. And you can ignore some of that stuff. To actually read the text of the law is something you can do this evening. You can do it tomorrow morning over a cup of coffee. And it's very approachable. It's very readable. Section 4401 covers modular open systems approach for major weapon systems. Now, it is implied that this includes not only major weapon systems that you would think of an entire aircraft carrier, an entire fighter, an entire helicopter, an entire tank, an entire communication system. That is all true, but the definition of major weapon systems is also clarified in the law. It's anything that we're spending a lot of money on, right? So there's a lot of components that you would think of that by themselves may be independent acquisitions. Is that by itself a major defense acquisition? Is that a major weapon system, or is that a major weapon system component? All very clearly defined in the front matter of that law. So you'll be able to read it. It's got the definitions. It clarifies whether or not you're a component, whether or not you're a whole system, and what the implications are. It also clarifies the rationale for why a modular open system would be there. I've got a life cycle issue that implicates a rapid changing environment or threat. I have a technology that's going to go obsolete somewhere during the life cycle of the system. These are all clarified. You can read it directly in the law, and all the mystery starts to evaporate. Oh, well, some of these things actually apply for me. So instead of being hypothetical about it, you can be very specific. Do I have a major weapon system? Am I contracting for individual components in that system? Can I replace those components over the life cycle? Do I have a threat issue that could cause me to replace that component independently of the original provider? Do I have an advancing technology that's going to mean I'm going to have obsolescence or new technology insertion that I have to deal with? Start to lay those things out, mystery starts to go away. Furthermore, it's the idea of the budgeting side of this is also carried forward. So in the following sections, in section 4421 through 4425, you actually see the development for individual components and technology. And there's a footnote in the MOSA section that specifically says what we mean by component is this stuff over in this other section. So now you've got not only the definition for the business approach, the acquisition strategy, and the component level change that has to be addressed, including the lifecycle drivers that are necessary to consider. But then you also have the authority to be able to go out and independently contract within the budget you already have. You can independently contract, you can rapidly prototype, and you can replace throughout the entire life cycle with independent contractual freedom directly to the supplier. And it's very clearly laid out in the law. So if anybody says, well, yes, but I don't have a program line for budget or for authority to be able to go get those components independently, point them back to Title 10. Read it to them. You'll let the mystery out of the bag. Okay, so more on that later. I would just want to encourage everybody to go out and grab that link and just spend a little bit of time reading it. Okay. One of the other big mysteries that we had, and this was a myth I said we had a slide on, is that MOSA hasn't gone into practice. Nobody's ever put it on contract. Well, you know how sometimes you get the law and then it's not until somebody tries the case in court that the law is actually got precedence. And you might have heard that before in the news where, the legal precedence for this is based on some other court case. Well, in a lot of ways, in the contracting world, that's how the GAO functions. So the GAO made a decision on the future long-range assault aircraft, and the government accepted the more expensive proposal to the tune of $3.6 billion more expensive because MOSA was that important. And it hinged on MOSA and the architecture definitions of the aircraft that enabled the government to save money and make the changes they needed to make throughout the aircraft life cycle. So the total life cycle estimate for FLRAA is somewhere in the $70 billion that we'll spend as the American people maintaining the Future Long Range Assault Aircraft weapon system. It was worth it to the government to be able to say, we'll spend more money up front to get the freedom of action and the ability to make changes over the life cycle of the system to be able to do that upfront work for modular open systems. And the GAO not only supported that decision, but it gave great precedence. So in the on the left hand side of this slide, I guess it's the left hand or the right hand side of the slide, right hand side of the slide. I'm looking at it backwards on my screen. Sorry. In the white text, you see the actual quotes from the GAO report. In the orange text, I've made some observations. Those are just John's opinion. You don't have to take any of those seriously. Now, obviously, the approximate $3.6 billion decision, that's not an opinion. It actually states that. But what it is, it does give some justification, in my opinion, for the government to say an open systems approach can be worth more and it can provide justification for making a more expensive decision on the part of the acquisition agency. That's good news to innovators. That's good news to contracts, because one of the questions is, well, if MOSA is going to displace me in a future program, how am I going to recoup my initial investment? Well, the answer is put your initial investment into the cost in the current life cycle. And if you're able to lower that in, compete on price in the future, or if a lower cost competitor comes up in the future, you've still got competition room. The government can then make the decision. This is the best decision that we can make right now, even if it's the more expensive decision, and we have the choice to recompete it in the future. So that balance comes out as really good news for innovators. Okay, I'll keep going with this. You'll get the slides, and I will encourage you. There's the link at the bottom. You can read the entire GAO report, and now you have precedence to drive this forward. Okay, we're running. We're gonna be very quick with our total webinar. Don't have a lot of time to get through the details of this, so I want to deal with the issue of MOSA is more than just standards. This chart's been around for a while. There's another link out there for a publication. Thanks to some good friends that in the early days of hashing out MOSA in the trenches. Particularly Bob Matthews, who former Navy program manager, went on to L3 Harris. I know many of us on the call know him. Several of you that are new to the Catalyst community have never met Bob. But the idea that we were talking about, well, there's all these standards, and there seems to be a standards war, and you'll still hear echoes of that in the history books of MOSA. But most of that has been resolved now. We have done tremendous work on standards interoperability, and we recognize that standards have a place, that you're not going to be able to get one standard that rules them all. They're deep in some areas, broad in some areas. They cover specific domains. They're good for software. Some are good for hardware. Some are good for communications technology. Some of them include different definitions of data models and abstraction from safety critical systems. Some of them are very specific to radios. Some of them are very specific to sensors. But the idea is that you recognize that because you're building a system from all these complex parts, you probably don't just have one standard as the answer for MOSA. In your complex system, you probably have several standards that apply. And in fact, you may have one standard that applies in multiple areas, and you may have other standards that are very, very specific to one area, but they're exactly the right standard. So it's helpful to understand that total ecosystem. And as a practitioner, one of the things you want to do is avoid a stakeholder who says, just tell me the right standard to put on contract, because they're looking for an easy button if they say that. And what you want to say is, standards, just like in your car, apply to a specific thing. I've got standards for tires. I've got standards for oil. I've got standards for wrench sizes. I've got multiple standards that are necessary to be able to create a modular and open system. Pick the right standard for the right job, and don't try and make one standard a hammer. So where does this? Okay, there's a lot of stuff about defense here, but MOSA is not just a defense issue. So one of the other ways that we can clarify or demystify MOSA is to recognize that it applies to other things. There's a lot of dual use interest in MOSA. For example, there's a tremendous amount of interest right now in urban air mobility. How do we get to self-driving cars or flying cars, and autonomy, and what's going to be the impact on civil aviation for all of the UAVs and even manned aircraft or uncrewed aircraft flying in conjunction with a crewed system that I can fly with just a driver's license. If I'm going to get to the point and sometime in the near future where I can affordably purchase a 4-person urban air mobility craft of some kind and fly it from my house to a neighboring city as a commuter vehicle, charging it with the electric power grid, modular open systems has tremendous implications to the future of our civil infrastructure. So it's not only the safety critical systems themselves, but also the way that those safety critical systems connect with critical infrastructure. Let's talk about nuclear power modernization, or resiliency in the energy grid, or industrial control systems that might be implicated in water and wastewater, in robotics and all those kinds of things. We recognize that MOSA and all the things that we have learned in defense are going to have tremendous dual use potential. But even just within the DoD, the crossover to digital engineering, mission engineering, which talks about complex systems of systems in the hands of a warfighter doing the actual thing, to be able to make a component level replacement and see what the impact is for the mission, for the warfighter's actual implementation of that technology. What about simulation and training? Again, you train like you fight, you acquire like you fight. We're going to have to simulate like we fight as well, which means that we want to be able to put those modular systems into play rapidly. And then testing. Now, one of our keynote speakers at the last MOSA Summit was from Department of Test and Evaluation, Honorable Doug Schmidt. We expect to see a whole lot of changes here, but it's more than just DOT&E. It's also incremental testing. If you've been in the software world long enough, you know about unit testing and test first kind of development technology, where you write the unit test at the beginning and then you write the software until the test finally passes. You've got to understand what the implications of testing are in your development cycle, not just in your final operational use test. So there's a lot of crossover where the MOSA principles that we're building are going to have implications to every other aspect of our acquisition and our integration of that acquisition into the larger system of systems, and the integration and blurring line between defense and critical infrastructure. So MOSA is a core issue. I like to say it's not just one of the threads, it is the fabric itself. Okay, so moving on. Where do we go from here? One of the main issues that I think we're going to have to deal with, and this is my last slide before we get to some questions, is that how do we drive change into this? Well, okay, if we can walk through MOSA as a legal requirement that applies to more than just the technical domain, it's not just software, you can't just solve it with a couple of standards. Those are all the things that, okay, well, you've told me a little bit, MOSA is bigger than that. It's not just this. It's a business. It's breaking a large complex system into small incremental parts that I can change rapidly. I've got contractual authority to do it. I've got budget authority to do it. Okay, you've convinced me. I'm a stakeholder. You've walked me through this. I understand a little bit more about MOSA than I did before. I've seen examples of people putting it on contract. There's a vibrant innovation ecosystem out there. There's proof of concept. There's a large pool of practitioners. There's dual use potential. Okay, I'm convinced. Your stakeholder says that, and they say, now what? Well, the question is, how do you then move the needle forward on defining MOSA in a way that is more than just the implications of that one system? I will say that this moves beyond the legal requirement. The legal requirement is on an individual weapon system. So your singular weapon system is the one that has to have an approach that's appropriate for your weapon system. Here's one of the rubs that we have. I think this is an area we need to work on as a community. We recognize that weapon system A and weapon system B have similar approaches, right? I have two separate weapon systems, and in one of the weapon systems, I have a communications technology. In the other weapon system, I have a communications technology, and they're very similar. Are they identical? Probably not, but they're similar. Is there some modularity that can be shared between them? Now, that doesn't necessarily mean an identical component, but what it might mean is an interface that can allow competition at both levels to improve and exchange information. So this means that we have to take a DoD-wide enterprise strategy. We have to think about the whole organizational business model. We have to continue to foster competition at the component level, because what's good for one program may not align timing wise with what's good for another program, but the innovations I learned on this other program might be good for the next increment of the first program. So we have to start thinking about an enterprise level approach for this. And when we say enterprise, we mean enterprise at all of its layers. Enterprise for Army aviation across individual weapon systems, enterprise for the Army across air and ground systems, enterprise across the Army and the Air Force, the Army and the Navy and the Marine Corps. We have to have that enterprise approach then at the next higher level for mission engineering to understand how the components fight together. We also have to have a product line approach. We have to recognize that there are suppliers whose entire business model is only one subset of a domain. Maybe they're just communications providers, they're a radio company. Maybe they're just a software company doing mission planning software. Maybe they're just a hardware provider building mission computers. Maybe they're just a sensor company that they focus on sensors. So we recognize that as we take a product line approach, industry will adapt that product line approach to provide the kinds of products that we need. Sorry about that. All right. So, and there's some details that we could talk about. And then finally, the lifecycle management approach. How do we put this into budget flexibility and reach, for example, using OTAs, other transaction authorities, to get to the kinds of contractual flexibility that we're going to need in the future? How do we get to the testing flexibility we need in the future? So those are where we're headed as a community. And we're going to hit some of those themes pretty hard next year at the MOSA Summit. So hope you stick around with us, and I'm eager to answer your questions. Okay, that's it for my slides. Back over to Laura.
Awesome. Thank you so much, John. That was really helpful. And if you have questions, go ahead and pop them into our control panel here, and we'll begin answering some of those. So to start with, Link asked, why is UAFML not the standard versus SysML, as the former has $100 million in investment by the Department of Defense and MODS with full ontology and domain profile, while the latter is a general profile not to be used at DoD?
So I love the softball questions. Nice, easy, low technical bar for questions like that. So as you know, in the practitioner space, those of us that know UAF is Unified Architecture Framework Modeling Language, UAFML. Most people just say UAF. And then SysML is the Systems Modeling Language, and both of them have a pedigree with early software tools for UML and the understanding of complex systems with graphics. So here's the easy answer, right? UML and SysML are related. And in some cases, especially when I'm down at the deep component level, I don't need all of the business stuff that comes with understanding UAF. And we've got a number of practitioners in the community. There's a whole group led by Laura Hart between the Object Management Group and the National Defense Industrial Association, or NDIA, for model-based acquisition dealing with exactly this issue. So what I'll do is I'll encourage you to get involved with the Object Management Group UAF managed community, because the idea, the hope, is that UAF replaces DODAF. And that the next generation of DODAF 3.0, really is UAF. And that talks about the system and its architecture and how it's employed. But when I get to the detailed conversation of how the inner components of a system work, I probably need something a little more general purpose like SysML to be able to describe those technical contents at the component level. So I think you need both, and a good way to get involved in that conversation is the OMG, Model-Based Acquisition Managed Community.
All right, fantastic. Thank you. Another question comes from Robert, who asks, MOSA, as was in the original Tri-Service Memorandum, was FACE, SOSA, Victory, CMOS. What about other standards like UMAA for U.S. Navy and GARA for Air Force, and CISO standards for simulation? Do they have a place in MOSA as well?
Absolutely. And in fact, one of the things that I would really, really encourage you to look at is that inside of the Title 10 language, it doesn't define any of those standards. It says there's a standards hierarchy to be able to go from broadly adopted consensus-based industrial standards to the idea that you're going to have maybe a military specific standard if you don't have a commercial standard that you can use. And then maybe you get to a government produced specific fit for purpose kind of standard. And then you get down to purchasing the intellectual property at an interface so that you can license that and pay the person who designs it, design that standard that was really, really unique. And you want to still have freedom of action, so you can pay them a license for that interface, and then share it with who you need to. So that's all actually spelled out in Title 10. But none of the specific standards that you mentioned are in that ecosystem, right? And so you've got this standards ecosystem, but you also have other standards we haven't even dreamed of, standards that haven't been invented. And the congressional language was done, in my opinion, very correctly, because it said what the principle is, how to decompose that principle through that hierarchy to make a decision that's appropriate for your program. So, all of the standards that were mentioned, both the ones that were in the Tri-Services memo, which again predates the legal requirement. So the Tri-Services memo, the regulatory policy came first, and they picked some standards that were good examples. You can use any standard that's appropriate, starting with a broadly adopted commercial standard, an SAE standard, an IEEE standard, maybe a unique standard built by a consortium in the commercial space. They're all fair game for MOSA.
Okay, great. March asks, great FLRAA example. Are there other positive examples of which you're aware?
Oh
On
yeah,
the contrary, yeah, on the contrary, are there examples where cheaper bids that are not ensuring MOSA compliance are still slipping through? Trying to get a
absolutely.
broader sense. So,
Yes and yes. And oh, the tales I could tell. I don't want to throw any programs under the bus, so I'll be careful on the negative examples. And I think one of the things that we're trying to get at with the Catalyst community is to prevent the confusion that a program manager faces when they are under pressure, because they get their money later than we think they do, right? You think you get money every year from Congress, but you get it 3 months into the year, and then you have to get it on contract before that last 3 months. So you have 6 months to spend a year's worth of money as a program manager, and you're really, really facing down big challenges on being able to acquire those specific capabilities. So there's a lot of pressure on a program manager, and I don't want to minimize that at all. And so some of them make, I don't want to say necessarily rushed or bad decisions, but they can do better if they are well informed by this leading up to that critical decision point of putting money on contract. So there's lots of bad examples out there of people that have made an attempt, swing and a miss, but people are swinging at it now. What's more important is the people that aren't swinging at it at all because they haven't recognized it's coming. It's going to hit them, and it's going to hit them hard, because they're handing off a future bad decision by ignoring modular open systems, and some future program manager is going to have to deal with the side effects and the baggage of that. And unfortunately, there are far too many examples of that. There are other good success stories, right? So we are hearing about them all the time. We're hearing about them in the sensor space, in weapons open systems architecture. I think is going to be, our next webinar. I won't steal any thunder from that. But the Air Force has got a number of things that most people have never heard of that are applying open systems technology, as does the Army ground community and the C2 community. In fact, there are probably more success stories than there are history in MOSA, because we've been doing some component level acquisition really, really well for a long time.
great. Um, Another question from James. So, how would you answer questions about balancing optimizing cost and weight with modularity, which tends to sub-optimize or increase cost and weight?
Okay, so there's a myth that I want to capture for a future Mythbusters. Somebody that would say that optimizing for weight or power or any other thing is in contrast to optimizing for modularity. Um, so I will say this: modularity and openness are factors that you can consider when you are doing system level optimization, as are power, weight, maybe specific throughput, bandwidth. There are all kinds of things that you can consider. And at a detailed component level, you can say that modularity in this particular instance is a potential factor in suboptimal performance. But I'm going to challenge you to prove that. And I'm going to challenge you hard to prove that, because we've had a number of academic institutions that have been studying this for 20 plus years. And really, we found that the inverse is true, that modularity typically will bring me opportunities. Not only will I be able to optimize for these other things without sacrificing modularity, but more importantly, the modularity will allow me to regain power and weight over time as technology improves. Let me give you a great example. This cell phone, compared to an entire PBX, a laptop computer, a PDA, a note-taking device, and everything else. Well, this is both power and weight, far more efficient than what I could buy 10 years ago, much less 20 years ago. So you're going to put a suboptimal solution on there now and claim that modularity worked against you. No, that's a cop out. Don't do it. Don't take it. Don't allow it. It's completely BS. Now, at a specific component level, you may determine at this particular interface, having an integrated solution that couples two things together might bring me near term optimization for space, weight, or power. That might be true, but you better build a backup plan because that's not going to be true in 5 years. So at any one of those points, if you say it's this big of a box now, however, in 5 years, I'm going to replace it with three smaller boxes that give me independent freedom of action, and they're all going to be cheaper, faster, more powerful, and way less.
All right, great. Thank you. We have a little bit more time here, so we'll try to squeeze in one or two more. So Howard asks, how would you expound on how MOSA and testing intersect? What is the role of testing in MOSA compliance verification?
Okay, great. So I'll take that as a two-part question. So MOSA and testing, and then MOSA and compliance, right? So there's compliance and conformance. That's a whole can of worms. Compliance is like, I comply, I give up, right? Conformance is I am 100% correct. I absolutely conform. I am exactly what you expected. And there's a balance. There's a continuum, right? In some cases, compliance is appropriate. You comply and you gave it a best effort. You're meeting the intent and the spirit. You're maybe even leaning further forward than other people in that compliance, but it's difficult to verify 100% that you did it according to a standard. Whereas a lot of standards say, well, conformance, it either is or it isn't. It's binary, it's one or zero. You either conform or you don't. And in some cases, that's absolutely required. In other cases, the innovation is moving so fast, or we recognize that as long as the government has intellectual property at that interface level, or I have a boundary that allows me to replace that, maybe an abstraction layer, compliance is just fine. So testing on the other side of that has to do with the ability to identify smaller areas of testing surface area, so that I can validate that a particular subsystem works, right? It's Think about it this way from a software perspective, and I'm not just speaking to software people, developers, testers, requirements writers, but as software users. If I have a problem on my computer and I just get an error message that says, "I'm sorry, your computer can't continue because there's an error," that's not very helpful. But if I get a very specific error message and it says, your camera is not enabled, I'll use a message from today. Your camera is not enabled. You have to quit the webinar, go to system settings, enable the camera, and then start the webinar again. Okay, now we know what to do. So from a testing perspective, if I can identify the specific module where the error occurs, and then I can identify that the rest of the modules are correct, I might have a system level error, but I should be able to isolate that and remediate that cause to the component without having to chase all kinds of regression defects through the rest of the system. There are huge benefits to testing, not accounting for compliance and conformance, but just good system design, right? Who cares who measures it? From a tester's perspective, the more modularity I have, the better my system is going to come together.
All right, thank you, John. And that is unfortunately time, everyone, for questions. But if we didn't get to yours today, don't worry. We'll follow up with you. We'll make sure that you feel like you have the resources you need. And we'd, of course, love to see you here again. So our next webinar will take place at 2 p.m. Eastern on September 4th. It'll be entitled MOSA for Air Force Weapons Using WOSA, where we'll feature Jonathan Shaver, who's the creator and government lead of the Weapons Open System Architecture Standard. So please join us, bring your questions, and have a great afternoon.